This is the continuation of our lesson in generating patterns. This is the part 2 of the discussion. Still, the learning competency is to generate patterns. But let's have a sort of review. The direction is to arrange the jumbled letters to form a word defined or described by the statements. This is the first one. It is a conclusion made from an observed data or an educated guess based on patterns. Very good. The answer is conjecture. The next one. It is a set of numbers or figures which is written in a special order based on a definite rule. Correct. The answer is sequence. Here's the third one. It is represented by A sub n. Hooray! The answer is nth term. And the last one. It is an observable rule. That's why we generate the terms of a sequence. Yes, the answer is pattern. It seems that you learned much from the first discussion. We're about to begin now the second part.
Sequences are classified as finite and infinite. A finite sequence contains a limited number of terms. The number of terms can be counted. This means it has an end or last term. For examples, the days of the week is an example of finite sequence. Why? Because we have only 7 days in a week. We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Apparently, the last term is Sunday. Another are even numbers between 12 and 24. When we say even numbers, these are numbers that when you divide it by 2, the remainder is 0. So what are these numbers? We have 14, 16, 18, 20, and 22. But we don't include 12 and 24 because we are only talking of even numbers between them. And the last term here is 22. On the other hand, an infinite sequence contains a countless number of terms. The number of terms of the sequence continues without stopping or it has no end term. The ellipses or the 3 dots at the end of the list shows that the sequences are infinite. This is also read as and so on. For examples, the counting numbers or the natural numbers. In elementary, you talk about successor property. It states that after a given number, there will always be a number next to it. In the natural numbers, after 1, the next is 2. After 2, the next is 3. Then followed by 4, 5, 6, and so on. So here, we cannot determine the last term of the sequence because after 6, there are still numbers next to it. Therefore, the counting numbers is really an example of infinite sequence. Next example are the multiples of 3. In the first part of our discussion about generating patterns, multiples are the products that we get when we multiply a certain number by the counting numbers. In this case, 3 will be multiplied to the counting numbers 1, 2, 3, 4, and so on. With that, we can get the list of the sequence. And these are the terms: 3, 6, 9, 12, 15, 18, and so on. Activity 1. List the terms described by each rule of the sequence. Then determine if the sequence is finite or infinite. Number 1. Add numbers greater than 21 but less than 35. When we say add numbers, these are numbers that when you divide it by 2, the remainder is 1. So what are the terms of the sequence? So we have 23, 25, 27, 29, 31, and 33. Our last term is 33. Therefore, this is a finite sequence. Number 2, the set of primary colors. There are only 3 primary colors: red, blue, and yellow. Since we have 3 as number of terms, the sequence is finite. Number 3, prime numbers. Prime numbers are numbers with only 2 factors, namely 1 and itself. The terms are 2, 3, 5, 7, 11, 13, 17, and so on. But since we cannot determine the last term because there are still next prime numbers after 17, this is an infinite sequence. Patterns in the sequence can be obtained by using a rule that can be written as description or using a general term. A general term can be a formula or an equation. A sub n equals 2n is an example of general term, and a sub n is the general term or the nth term of the sequence. Activity 2, let's solve. Letter A. Given the general term, give the first 4 terms of the sequence. Since we are getting the first 4 term, your n should be substituted by 1, 2, 3, and 4. For number 1, a sub n equals 3n plus 1. A sub 1 equals 3 times 1 plus 1 equals 4. A sub 2 equals 3 times 2 plus 1 equals 7. A sub 3 equals 3 times 3 plus 1 equals 10, until we get a sub 4, which is equals to 13. So the terms in the sequence are 4, 7, 10, and 13. Number 2, a sub n equals n all over n plus 3. To get a sub 1, we will substitute 1 with your n. A sub 1 equals n all over n plus 3 equals 1 all over 1 plus 3 equals 1/4. A sub 2 equals 2 over 2 plus 3 equals 2/5. For a sub 3, change n with 3. So we have 3 all over 3 plus 3 equals 3/6. Find the lowest term, and the lowest term of 3 over 6 is 1/2. For a sub 4, this is equal to 4 over 4 plus 3 equals 4 over 7. So the terms of the sequence are 1/4, 2/5, 1/2, and 4 over 7. These are the first 4 terms of the sequence a sub n equals n all over n plus 3. Letter B. Find the indicated term of each sequence given. Number 1. A sub 4 of a sub n equals negative 2 raised to n plus 1. Substitute 4 to your n. A sub 4 equals negative 2 raised to 4 plus 1 equals negative 2 raised to 5. On the next step of the solution, we use parentheses in order for you not to be confused, because the only term that is raised to 5 is only the term 2 but not the negative sign. So 2 raised to 5 means multiplying 2 by itself 5 times. So the next step is negative quantity 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. So a sub 4 equals negative 32. Number 2. A sub 3 of a sub n equals n square minus 5n plus 1. So we will change n by 3. A sub 3 is equals to 3 square minus 5 times 3 plus 1. A sub 3 is equals to 9 minus 15 plus 1. The answer now here is a sub 3 equals negative 5. For activity 3, letter C, follow these concepts. Number 1, if you add or subtract a constant number from one term to another, use a sub n equals a sub 1 plus quantity n minus 1 times d, where n is the number of terms, a sub 1 is the first term, and d is the constant number you add or subtract from one term to another. Note, d is a positive integer if from one term to another you add a constant number, and it is a negative integer if you subtract a constant number. Number 2, if you multiply or divide a constant number from one term to another, use a sub n equals a sub 1 times r raised to n minus 1, where n is the number of terms, a sub 1 is still the first term, and r is the constant number you multiply or divide from one term to another. Note, r is a whole number if from one term to another you multiply a constant number, and it is a fraction if you divide a constant number. Number 3, if the sequence didn't follow the rules discussed in numbers 1 and 2, we need to discover another pattern to find the general term of the sequence. Letter C, write a general term based on the pattern or rule described by each sequence. Number 1, 3, 12, 48, and so on. From 3, how did you get 12? From 12, how did you get 48? Yes, the operation used is multiplication. The number we multiply is 4. Your a sub 1 is 3. Since we use multiplication in order to get the terms of your sequence, the equation we will use is a sub n equals a sub 1 times r raised to n minus 1. Just substitute a sub 1 and r. Then, our general term here is a sub n equals 3 times 4 raised to n minus 1. Number 2, 25, 17, 9, and so on. What did you observe in the given terms? How did you get the terms of the sequence? Right, the operation used is subtraction. You subtract 8 from 25 in order to get 17. Same with 2, with 17 minus 8 is 9. So your d here is negative 8. The first term in the sequence is 25. Substitute a sub 1 and d to a sub n equals a sub 1 plus n minus 1 times d. So we have a sub n equals 25 plus n minus 1 times negative 8. Distribute negative 8 to your parentheses. A sub n equals 25 minus 8n plus 8. Therefore, the general term is a sub n equals negative 8n plus 33, or a sub n equals 33 minus 8n. Here is the third one. What did you observe in the sequence? Here we use division. We divide 3 from one term to another, so your r is 1/3. Your a sub 1 is equal to 270. Substitute a sub 1 and r. So the general term here is a sub n equals 270 times 1/3 raised to n minus 1. Number 4, 1/3, 2/4, 3/5, 4/6, 5/7, and so on. Using inductive reasoning, how will you describe the terms of the sequence? What will be the conjecture? Both numerator and denominator use concept 1, where from each term to another we add 1. Both parts of the fraction has d equals to 1, and use the equation a sub n equals a sub 1 plus n minus 1 times d. Substituting a sub 1, which is 1 in the numerator and 3 in the denominator, we have now this solution. Therefore, by simplification, the general term now here is a sub n equals n all over n plus 2. Don't forget to like and subscribe. Thank you for watching.